Hi everyone, Jacob Howard here, and in this video we're going to discuss video transmitters. Video transmitters are really what ties the whole FPV experience together, as their primary purpose is to provide low latency video from the perspective of your drone to your goggles or monitor so that you can maneuver the drone without crashing. There are currently both HD and analog video transmission systems available to FPV pilots, which we will discuss in more detail later in this video. Video transmitter and air unit. The video transmitter is often referred to as the VTX because it sends the video signal from your drone to your goggles. Another term you will hear when discussing FPV video transmission is air unit. An air unit is a video transmitter that works for the DJI digital FPV system. It is important to understand the difference between analog and HD FPV systems before making any decisions. Currently, the only released system for HD FPV is the DJI system. The DJI system has been well tested and is fairly easy to use and can certainly be used by a beginner. The HD FPV world is very new though, entering the scene around August of 2019. Analog FPV systems, on the other hand, have been around since the early 2000s. Deciding between HD and analog can be difficult since each provides unique pros and cons. The biggest and most obvious difference is the video quality that results in your goggles. Analog FPV video looks like this. As you can see, the video is grainy and not detailed. For many years, this was the only way video could be transmitted with a low enough latency to be able to fly without crashing. Digital video signals require much more data to be sent and processed, which can result in delays or latency from what your drone is experiencing versus what you are seeing. This is why a low latency system is extremely important. DJI was the first company to create a system that provides higher definition video like this to FPV goggles without latency. You might be saying to yourself right now, why in the world would I ever choose analog when it looks so bad? Well, there are some definite cons to the HD system. The biggest one being price point. You can expect to pay about $520 for DJI goggles and $180 for the air unit and FPV camera. However, with an analog system, you can get a good pair of goggles for $100, a good VTX for $25, and a camera for $25. The other drawback with the digital system is range. There are videos of pilots going up to 3 miles out with the DJI system, but this is an open air, and many pilots using the DJI system have discussed range difficulties beyond about a mile. Analog systems, on the other hand, have been in development for almost 15 years now, and there's extensive research into how to achieve the best results for long range. One final drawback of the current digital system that is worth mentioning is the size of the components. Because the air unit is so much larger than an analog VTX, it is advisable to select a frame that is designed for an air unit. Otherwise, it may be difficult to find space for the air unit and your other drone components inside the frame. Power ratings. Whether you are using an analog or digital system, VTXs output video at a specified power rating. This power rating is in units of milliwatts, and the higher the value, the more range and penetration your VTX will be capable of. For close range flying in open air, 25 milliwatts is sufficient, but for flying long range in mountains or at abandoned buildings, power ratings of between 800 to 1000 milliwatts are desirable. The air unit is capable of outputting up to 700 milliwatts by default. For analog systems, the VTX power capabilities will be listed in the product specifications. For tiny whoop size VTXs, you will rarely see a system that can do more than 200 milliwatts, but for larger systems, an 800 milliwatt maximum is fairly standard. Smart audio and frequencies. The typical frequency for most VTX on the market today is 5.8 GHz. This provides ample range and penetration for most purposes. However, there are video transmitters available in different frequencies for various specialized purposes. But just because a VTX uses the 5.8 frequency doesn't mean that it is outputting video at exactly 5.8 GHz. Instead, VTXs are configurable within a small spectrum of frequencies. Typically, these fall in the range of 5645 to 5880. These numbers are used as channels to enable multiple pilots to fly at the same time without interfering with each other's signals. The air unit will handle this channel changing automatically and select the best channel without any extra input from the user. Analog systems, however, require the user to decide, and this can be a hassle sometimes. The channel can be adjusted via your firmware configurator, such as Betaflight, but this requires a computer and a micro USB data cable, which you might not always be able to keep with you while you're flying. The other way to change your VTX settings is through a protocol called Smart Audio. Smart Audio is a deceiving name because it doesn't really have anything to do with audio. Instead, it gives the user the ability to change various drone settings like video frequency, output power, tuning parameters, and more through your VTX. In order to use it, you will power on your drone and navigate the Smart Audio menu in your goggles with your transmitter. This is the best way to configure your drone settings in the field. FCC regulations. It is important that we mention here that there are some regulations that affect the use of FPV video equipment. These rules are put into place by the FCC, or Federal Communications Commission. There are a few channels that are not allowed to be broadcasted on, however, these are usually limited by your VTX and you won't be allowed to select them. Output power is also limited to less than 1000 milliwatts or 1 watt. If a pilot wished to operate outside of these regulations, they would need to obtain a ham radio license and any special permits. Antenna connectors. All VTXs and air units use antennas to transmit the video signal back to your goggles. There are multiple considerations when selecting an antenna. The first thing to consider is the connector type. Antennas are made from coax cable, which is a wire that contains an inner conductor surrounded by a conducting shield. There are various types of coax connectors, the most common of which is SMA. You may have seen SMA style connectors used in old TVs. Most antennas will use SMA connectors, however, for a VTX board, these are quite large. There are other small coax connectors that are used more frequently on VTX boards. The most common ones you will see are U.FL, U.FL IPEX, and MMCX. These are all very different, and it is important to know which kind of connector is on your VTX. Often pilots will use what is called a pigtail to convert between one of the smaller coax connectors to an SMA style connector for their antenna. One more distinction to be aware of is the difference between SMA and RP SMA connectors. The difference is whether the center connection is male or female. Here you can see the difference between SMA female and male, and RP SMA female and male. As long as you are aware what kind of connector is on your VTX and that your antenna uses, you can select the correct pigtail to match the two. Antenna types. When selecting an antenna for your VTX, it is important to understand the difference between circular polarized and linear polarized. Polarization in this instance refers to the way a signal travels through space. In the case of linear polarized antennas, the signal path is in one plane only, whereas for circular polarized antennas, the signal path is in the vertical and horizontal plane like a spinning corkscrew. If our drones were flying in one direction only and doing no flips or rolls, a linear antenna would be best for long range because all the signal is focused in one direction. However, FPV drones were designed to be acrobatic, so linear antennas don't always work well for long range. Linear antennas are, on the other hand, very durable and cheap to manufacture. So if you were designing a drone for close range flying, a linear antenna might work great for you. In most all other scenarios, a circular antenna will be the best choice. The next thing to understand is the direction for the polarization in antennas. Typically, you will see directional or omnidirectional antennas. Omnidirectional antennas essentially transmit video signal equally in all directions, whereas directional antennas send the video only directly away from the antenna. Directional antennas work great if you can be pointed directly at the target. However, again, with FPV drones being acrobatic, this does not work well for most purposes. Most antennas used on drones will be an omnidirectional antenna. As we mentioned before, in order to fly with multiple pilots at once, various frequencies will be used. Another method to enable more people to fly at once is using right-hand or left-hand circular polarized antennas. This essentially references which direction the corkscrew shape is going that we discussed earlier. Many races will require pilots to have right-hand and left-hand antennas available. Make sure when you are purchasing antennas for your goggle and VTX that they are either both left-hand or both right-hand polarized. Mounting antennas. One last bit of information that is worth mentioning in regards to video transmission is antenna mounting strategies. You may see long-range video antennas that are extremely long. This is because the further away you can get your antenna from the drone, the cleaner the video signal will be. However, the longer it is, the more likely it will be to break in the event of a crash. Many racers and park flyers will use stubby antennas which are extremely durable, but are close to the frame and perform poorly in long-range use. Antenna mounting takes pre-planning and consideration. Video transmitters are vital to a successful FPV experience, and proper selection and pairing of VTXs and antennas can make a huge difference. Hopefully now you feel equipped with the information necessary to select and use a video transmission system on your drone. But if you guys have any questions, definitely let me know, and have fun flying.